Chapter 5, Part 6, Reactions of Alkynes and Drawing Alkynes and Their Products. Now, there are many reactions of alkynes that follow this electrophilic addition process, but the only ones that we're going to cover in this course are simply the reductions of alkynes. And these reactions are actually very memorizable, and I highly recommend that you create flashcards for these. So the first one is that if you have an alkyne and two equivalents of hydrogen gas and a transition metal, you will make an alkane. So we take an alkyne, add in hydrogen gas. It may or may not say two equivalents or excess or some sort of indication that there's plenty of it, but your hint will be that you have a transition metal down here, typically palladium, platinum, or nickel. And what that's going to do is on each carbon of the alkyne, it's going to add two hydrogens so that this becomes an alkane. The next one is alkyne plus hydrogen gas plus something called Lindlar's catalyst, gives you specifically a cis alkene. So those hydrogens that are being added end up on the same face. And then anything that was attached to the alkyne carbons will end up cis to each other. This is because this follows a very similar mechanism to our catalyzed reactions on the previous page, or sorry, in the previous video with alkenes. I also want to say on Achieve, they didn't have a lot of practice problems that involved Lindlar's catalyst. So they use another one called the P2 catalyst. And this is going to do the same thing. It's still going to give you that cis alkene. Okay, and then our third one is alkyne plus either lithium or sodium metal. Notice that they are both group 1 metals and they are right next to each other on the periodic table. And ammonia gives you a trans alkene. So notice our hydrogens end up trans to each other. And we indicate this by showing that whatever was attached to the alkyne carbons originally ends up trans. So the reason this slide exists is purely for kind of my sanity, but also yours when you're using Achieve. So here are some notes to remember. Alkynes are linear because they're sp hybridized. So this is a correct way to draw an alkyne. This is incorrect, this is incorrect. And drawing even more like severe angles so it really looks like an alkene is even worse. So please do not draw your alkynes with any sort of wonky bond angles. Keep them linear. And then alkenes are trigonal planar. So when you start drawing things like this, not only are you kind of wrong, but Achieve kind of stops being able to read this correctly. Achieve only reads the carbon atoms when it's grading your work. And I've seen students who, started off with their linear alkyne. They want to indicate that they made a cis alkene. And so they think, okay, well, I can just put my hydrogens on the same side, and that makes these cis as well. But it doesn't. And Achieve won't know how to read that. And you're going to get stuck in a loop where you know that you've come up with the right idea, you're just not drawing it correctly. So make sure that if you are drawing a cis alkene, that you are showing that with the carbons and not with hydrogens. And if you're drawing a trans alkene, again, make sure you're showing that with the carbons and not the hydrogens. But I wanted to show some examples that I've seen and the frustrations that that cause for students. I've seen, again, students start off with the correct linear alkyne, and they try to indicate that their alkene is trans by putting the hydrogens trans. Again, to Achieve, these two answers are identical because it's not reading the hydrogens. So it doesn't know what you're trying to say. But then also sometimes students end up doing really weird things where their carbons are actually cis to each other, but they've drawn the hydrogens trans, so they think they're okay. But Achieve is reading this as cis. And so students end up just kind of in a loop where they've tried the question over and over, they feel like they're right, but it's just because they're being stubborn and they don't want to redraw their entire alkyne, because the alkynes are typically not this short. They're usually something like this, and then they have, you know, a whole bunch of carbons this way and a whole bunch of carbons this way. And students didn't want to redraw the whole structure because they had to adjust the bond angle in here. So just do the work, and I'm sorry that it's an extra step, but it will make your life easier if you just do it right the first time.